Welcome, everybody, to our first podcast. My name is John Conway,
And I'm Raminderpal Singh.
and today's topic is, can AI save the data culture challenge? We're going to talk about culture in detail. We're going to talk about data. We're going to talk about AI, and then what is the data culture challenge? So, kind of let's get this off. I think a very important point to emphasize is culture. And actually, culture is the foundation for not only how things happen or get done, but how organizations and people and ideas can come together and make change in the world we live in today. So, I mean, how would you define culture, Raminder Paul?
Yeah, no, thanks, John. And you've got more experience than I have. So I've only experienced culture as opposed to, coached culture. But every time I turn up in a company, whether it's small, medium sized, or large, and work for these different companies, they have a way, a kind of an unwritten way of behaving. And sometimes they try to codify that in these kind of statements, about how we think, how we operate. But there's an unwritten way how they behave. And if you conform to the unwritten way, you kind of have some tailwind. And if you don't conform, you have some headwinds. And that's how I see culture. I mean, what do you think? Is that your experience?
Yeah, yeah, no, absolutely. I think we have so many examples of how culture provided change in the world. And you can go all the way back in early human existence, right? So, examples would be um, hunter-gatherers going to farming, right? That took culture to change the way humans behave, the way they got their food, right? And that wasn't a widely adopted or immediately adopted thing. It took time to go from that hunter-gatherer approach to farming, and that then farming led to communities near the farms, around the farms, and civilizations, etc. That was huge, right? But that was a perfect, very early example of culture change. And I think we could go through hundreds of examples since then, the Industrial Revolution, religions and adoption, major organizations or institutions, the rise and fall of them, the Renaissance period. You just keep going on. But now we're in this extremely um, interesting, I think, data culture where our world has changed rapidly around us, faster than many other things that we've seen in our lifetimes. And it's very interesting. And I think this is kind of where we do the deep dive. It's been kind of teetering for 30 years, but now with the technology that's been put in place, it's taken off like a rocket. And you know what we thought 3 months ago, or the usability 3 months ago, has completely changed in AI, for example, in the use of large language models and things like that. So I think that's where we're at, and I think it'll be interesting to see what you have to say, Raminder Paul, what my thoughts are on how this is going to progress and where this is going.
Yeah, no, that's good. That is. So your point is that prior. So let's say there was a chasm moment, 30 years, and with the onslaught of cheap data, suddenly we have, let's say, in the scientific workflows and scientific communities and companies, suddenly there was a dearth of data, and now there's a plethora of data, loads of data everywhere, and that has changed culture. Could you what I'm interested in to know is, could you comment on how has that changed? Of course, it changes the way we operate because there's more tools and there's more software, there's more hardware, and there's more widgets we can play with because it's cheaper with all the data flow. We can take advantage of the data processing and AI. But culturally, how has it changed, for example, what a scientist is with this plethora of data, this massive wash of data? If I was coming out of a lab 40, 50 years ago, compared to if I'm coming out of a lab now.
Yeah, exactly. I think even today, educational institutions are not doing a good job and we're going all the way back to grammar school, right? It's going to have to go back to grammar school where kids are learning the value of data, why it's important, why the culture around it's going to be very important, why it has to be curated, why it has to be a focal point. And the end result is everything we do in generating scientific data to get the most out of it, it really has to be what we call model quality data, right? So that we can use it in a secondary, tertiary, even quaternary approach, a reuse of that data so that the science becomes more efficient. It becomes a in silico first approach where scientists are able to simulate um, experimentation, um, computational approaches, whatever that may be, in order to head off the level of effort it took years ago to do this so that we can become more efficient. And I think ultimately what's driving that, it's nothing earth-shattering, is that human beings are looking to find ways of staying healthy or or combating disease or disorders to have a higher or better quality of life. You could go to the extreme with that, where even some people might be thinking, hey, I want to live forever, or I want to live to be 150 years old, or whatever that is. There's an element of that in there, but it's really about the pursuit of healthiness, disease free, and quality of life. And that efficiency gain to combat or to cure or to prevent disease, which is the ultimate, if you think about it, how do we prevent that from ever even happening? Um, is driving this, right? How do we get better at it? How are we more efficient? And how do we prevent someone from ever suffering with some sort of disorder or disease state?
Yeah, so I mean, let's use the word driving. That's a good word. So you use efficiency, or let's say data is driving, and data is creating data processing, AI, etc., which is driving. But in the back when, it was know-how which was driving, right? So you come up
Mhm.
through the system and you would learn about biological processes and chemistry, and then you would learn about, how the body works, and your depth of knowledge would be the controlling knob, right? But today, it feels like that's being seconded to the data, the insights from the data is the driver. Do you have any comments on that?
Yeah, this is a very interesting concept. I think that's absolutely true, but I still feel that knowledge is power, and the more that you can know as a human being and understand and apply your human intuition to it, your ability to be creative, to innovate, that's never going away. But because what's going to happen is AI just drives that need higher and higher for people and humans to be more innovative, more creative, take all that in and make higher level or even better decisions, right? So people talk about, oh, people are going to lose their job. Yes, certain types of individuals or employees may be relegated to other things, but there's always going to be that need for intense, driven scientists who want to learn and know as much as they can
Yeah.
to use these tools to make much better decisions. And I think that's where it's going.
Yeah, and I think you're onto something. But I want to come back to culture.
Hmm.
What's the difference between data culture and, say, scientific culture or know-how culture? Because there is, in my eyes, that there is a difference now. If I come through the university system, like you rightfully said earlier, from grammar school up, you know, today I'm a scientist who used to using computers. They weren't back when. So
Right.
there's a difference. Use the word driver. I like that. There's a different driver in the way I operate. How is that? How has data created a different environment? Different. How am I viewing? How are my optics as a scientist changing because of the onset
Yeah.
of data?
I actually think it came out through evolution. Many scientists became, and now again, we're talking industrialized science, but even academics, government are wrapped into a data-driven approach, right? Um, and that's really what this is
Yeah.
about.
Yeah.
It's a data-driven approach to what we do. And if that is like the limiting factor, then you have to go all in on that model quality data, which means there's a whole level of detail and rigor and almost protectionism that you have to put into your data culture or your data approach. You have to guard it, right? Like all culture, you have to guard it. You have to make it part of your DNA as a person, as a scientist, as an organization.
I think you've hit onto the key point. I mean, what you're implying is that people go, they have their traditional ways, and then they lean towards data as machines come live, as CROs, for example, are providing more data, as they can get more things off the web, but they do more crunching. But they're not, as you say, going all in. And if they're not going
Correct.
all in, they've got a hybrid environment, and then actually the data, because as you said, the models are not well formed because it's expensive to get it all right. What's happening is that they're actually creating problems, and then they're having a bad experience with these data-driven flows. Is that right?
Absolutely. Let's look at one of the common problems with journal data, right?
Yeah.
There's a belief out there that at least 50% of the articles, the scientific articles, are not worthy of, good science, good data, etc. But unfortunately, we're at this point where a lot of that data is being ingested and consumed, and and this contributes to things like uh, poor model outcomes, especially in large language models. Maybe there's hallucinations because, again, this data is part of the fabric that's being used to suggest or advise from a large language model, et cetera. So we have a challenge there. We have to get beyond that. We almost have to root all of that out, and that's going to take effort and time, and a data culture to replace that today and and this has already started to happen. This has been going on for a couple of years now, where that data quality, the journal articles are very detailed, where the data came from, what the data is, what the models are, how they've been used. It's all been very transparent. And that type of thinking, that type of data culture, that is going to drive excellence in the now and in the future with our AI approaches. We will get rid of things like misinformation, um, sources of truth, confidence levels. I say this all the time. Our informatics is in its infancy because we have so much room to grow from a contextualization perspective, a metadata perspective, et cetera, and even a confidence, including percent confidence in the data that's being used, including examples of where and how the data has been used multiple times to, again, increase accuracy and things like that. These are where um, a very strong data culture is going to take the near future.
Yeah, and if we compare it to say something like fintech, banking, where data has been inherent for the last 20 years. And I mean, they've scaled their systems. I mean, they have day trading. The concept of day trading is amazing if you think about it. Where I think people can respond in a millisecond or a microsecond to trading sentiments. I mean, think about that. It's not that the trade happened and you're following it. Is there's a sentiment that a trade is going to happen and you're going to follow the sentiment. And they're triggering these things off. I remember 10, 15 years ago, working on a project, and they were looking at the cost of water. No, it's not cost of water, but some sort of analogy or some sort of standard to measure the cost of water against. But they weren't interested in the absolute. It was they were watching news on Twitter feeds at the time for how water cost could be going up or down, and they were trading against the momentum. of the water cost. And this was 10, 15 years ago.
Right.
Um, we bring that into, and that's very fast trading. You bring that into our world of science, various domains of science. There's so much possible. It may not be possible. It may not be our focus that it's happening in milliseconds or microseconds, but it is possible that we could scale our understanding, for example, of diseases and relationships between pathways, and clinical trials is a classic one, right? Or even materials, understanding of how materials interact in different environments. There's so much. And the other example I think is cool to give is things like spaceships. If you think of rockets and the way that they operate, with SpaceX and the different techniques they're using, they're able to model these things to such a degree that actually when they started testing their space rockets, the reusable, they knew they were going to fail. And they were doing live tests to take measurements to get more data to do better models.
Right. Exactly. And the interesting part about that is it's complex, but you can physically see it, you can physically track it, you can physically model it. And that's fantastic, right? In the life sciences space, this isn't always true. And this is this extra layers of complexity. However, now imaging is a perfect example of where the science in imaging is helping leaps and bounds in understanding, and actually for the first time being able to see things at the molecular level, even the atomistic level, right? And this has done amazing wonders for humans in the scientific community, and it's going to do nothing but improve and grow. And again, just the information around imaging is a perfect example of where if you don't have a good data culture in your imaging efforts, programs, uh, initiatives, whatever you're doing, you're gonna spend a lot of money and you're gonna come up short because you didn't guard the data that's associated, that's exploding with your imaging efforts, right? And it's very costly to not only the organization, but the scientists involved doing this work, but then the progress that you could have made if you would have done it right the first time.
Yeah, opportunity cost. I think imaging is a bit of a exception in our world, because imaging is something you can see and you can test and you can
Yep.
verify and validate. And imaging has already made big leaps and bounds in the clinical workflows, healthcare workflows. A lot of machines now use imaging. There's a charity in Spain. These guys go to some places South America and some places in Africa, and they'll take a $50 microscope, put some AI processing, in it, and they're able to see, resolutions down with respect to malaria detection in blood. And these things are very clear. And I argue that these things are because there's a single transaction going on. So if you have any relationship with people or with systems, if you have multiple complex things going on, sometimes things get hidden in those complex paths. Now, if you have a single transaction, I see an image, I can detect cancer in the lung. Okay, I see it, I can detect, I can compare that to a human, how fast, how well, etc. It's a transaction, it's a single layer. But if I have a complex thing going on, let's say I have a clinical trial, and in the clinical trial, I have multiple issues like recruitment, speed, recruitment costs, quality of the people, quality of the dosing, multiple costs, not just the drug itself. Then these things confound, you see. And now
Absolutely.
if I get a lot of data and I get a lot of analysis and I find something, I may be finding the right thing, but it could be subjective, or it could be an argued that I may be finding the wrong thing. And then it becomes blurry whether the data is actually helping me or not.
Correct. I think kind of what you're saying here is there's holistic approaches to this, and then there's very specific and detailed approaches. For instance, like you were mentioning about, the patient, you've detected a cancer in a patient. Maybe it's just a single tumor, but and that's fantastic, right? But what wasn't detected is what's the overall health of the patient besides that specific tumor, right? Are they able to participate in a clinical trial? Are they going to make it through a clinical trial? Like there's all this level of detail that needs to be assessed. And this is today. This is where, again, strong data culture, strong AI helps make much, much better decisions for not only the health of the patient and their outcomes, but the investment needed and everything that goes into play from a clinical trial or experimental approach.
It does, but I mean, let's be a bit skeptical. We're devil's advocate here. It also creates a data fog. If there's so much data acquired, and let's say the data, you churn the data, and it gives you a view on a patient, and they're, as you say, they're, are they the right patient? Are they ready for this? Are they available? Numbers of attributes. The reality is that there's too much data to crunch to get a clear picture. So what people do is they reduce these models. If I have 1,000 variables in a situation, I'll reduce it to 5 variables, and then I'll measure each patient on 5 things, and then I'll put that into a Pareto, and then I'll pick the top, available, because I'm always constrained with clinical trials. I've got to get it going, and I've got to get, especially in rare disease, right? It's really hard. So what you end up doing is taking a very complex data situation and putting subjective human bias into it. And so you have a lot of people who will turn around and say, it would have been a lot easier if we were just to put the subjective human bias up front and just pick these guys, pick these patients. And that data fog, which I see in numbers of places, where people are not brought up with data as the center of their universe, and data crunching and data complexity, they get confused by these situations. That creates paralysis, and they end up running away from data-centric systems and just using data at the periphery.
Yeah, I agree. I think it's very similar to like a growing business where you have growing pains, right? Oh, that didn't work out well, or we didn't really know what we were doing, and we've got some lessons learned there. Um, just like again, having the right culture around that to say, to guide and to say, hey, here's our goal at the end here. We're going to have bumps in the road. We have to learn from these mistakes or these experiences, these lessons, and we have to regroup and move on. We have to regroup and move on to get to that end goal.
Are people able to do that though? I mean, reality, if I look around big companies, culture, once it's embedded, even mid-sized companies, even small companies, once it's embedded, and they've got their beliefs and their skeptical view of things, very hard to say, look, guys, we should learn from that, and we should come back around in a more robust way to data. People don't feel comfortable after a point. Scars affect them.
Correct. So you're bringing up, I think, a critical point. How do you set a culture at an organization, or even more difficultly, how do you change a culture, right? Because this is where we're at today in the world, and I think you'll have people that say, "Oh, well, it comes from the top down," and then you'll have people say, "Oh no, it's individualized. Everybody has to be part of the culture to be part of the solution." And the answer, in my experience, it's not even what I think, it's what I've experienced and what I've seen and what I've put personally in place, is that you need both. It's the sandwich approach. I joke around, I call it the Conway sandwich, but I didn't invent anything here. You have to have a CEO or the head of a company that is completely driving the culture from the top down.
Right.
And you have to have every individual in that organization that is guarding and promoting the culture in everything you do, right? It can't be, we're going to ignore it next week, or we're going to get to that next week. It's part of the DNA, and it's discussed constantly. New employee orientation is about that culture adoption and ways of working, and the CEO doesn't get vacations from the culture. It's part of everyone's DNA. When that happens, it's very successful. And you if you have pockets where the culture breaks down in the organization, that's part of operational management, right? You you fix that. It has to be fixed. If people don't fit into the overall culture of the organization, has to be addressed, because what it does is, it's unfortunately, it is like a cancer. It can eat away at the overall success of the company, when that culture erodes. Now, that and I think it's important not to um, mistake culture and cultism. Many organizations are very culty like. They have they're like a cult. They have their way. You brought it up earlier. They have their ways of thinking. They have their ways of doing thing. And from the outside, you look in and you're like, ooh, what's going on there? Why are these certain things happening? Why are certain things not happening? Right.
Right.
And it's the biases that get built in. It's this is how we've always done it approach. We don't need to do that. We're so and so. We're different. We're better. It's that mentality that drives massive inefficiencies in these companies. And they don't scale as an organization. They can grow, but it at some point they're a mess, and they can't get out of their own way, and they ultimately are failing in many ways, and they have a massive amount of opportunity for improvement. And there's been examples of this. We don't have to go into them now, but from a data culture perspective, there's been companies that have made massive mistakes when it comes to their data approaches, and how they look at data, and how it ended up affecting their outcomes. So, like, I think I recall, like, Amazon being data driven everything. Netflix is data fuels creativity. These are some of their mantras. Data
Even
first in biotech.
even Tesla car. So
Yeah.
Tesla car, right? I don't know if you know, but they don't use lidars. So lidars are the technology which every other car manufacturer uses, which can detect a physical object using radar. Tesla
Yep.
said, no, that's too expensive, not do it. And they've got cameras, and they are image driven as opposed to actually radar driven. And it's massively a data thing. It's all about data.
Absolutely. I mean, even LiDAR I use it for uh, looking for places to go to look at where there may have been a building 100 years ago. And where there's a building 100 years ago, there's a good chance there's old coins, and there's old things that you might be able to dig up and stuff. And so it's a I won't say advanced way, but it's a way of thinking that is more efficient, as opposed to randomly going and looking for places to look for. If, like, you're into metal detecting or whatever, and you just randomly go and look, your chances of finding something is much higher if you do that research with a tool like LiDAR. That's a perfect example.
Yeah, no, so I like that. Let's scroll back a little bit. You mentioned a few minutes ago about the sandwich, the Conway effect, now nicknamed forever in stone. But reality is, and we can see this with any change which comes into companies. So let's call it the McKinsey effect now. So McKinsey come in, or somebody comes in, a consultant, a contractor, a new executive, or a McKinsey type company comes in, and they'll say, we want you to become data and AI driven because it's better, it's faster, all this stuff. And the CEO says, okay, cool, I get it. How much it costs? And they say, it's going to cost several million. Fine. Let's find the budget for several million, or let's raise several million, and let's pivot, or not so pivot, but let's gear ourselves as a company from being traditional and paper-based to being data-driven. So everybody's doing the rah-rah moment in the C-suite. But as you said, it's a sandwich. And what I've seen in, I say again, small, medium, large-sized companies, it doesn't actually matter. But what I've seen is that they'll send the word through. They'll have the all hands meetings. they'll have the memorandums, they'll have the, instructions, like cloud first or whatever first, AI first, data
Right.
first. But the same people are on the shop floor doing the work.
Correct.
And those same
And
people.
suffering. So now you've taken, let's you just keep it in the realm of a scientist or
Yeah.
somebody working in laboratory. Now you have somebody whose objectives were built on a 40-hour work week in doing certain processes, right? Whether there's automation in there or not. But there's paper involved. Their electronic lab environment is um, poor to non-existent.
Yep.
And all of a sudden you say, oh, guess what? You're going to change and
Yep.
you're going to make all these
Yep.
things happen in that 40-hour work week
Yep.
and you're going to get it done. Well, it's a great way to give a scientist a nervous breakdown, right? Because it really is. I mean, I could tell stories of for years and years, but it's completely unfair to the human worker, right? Instead of saying, oh, by the way, you need to spend now an extra 2 hours a week documenting this and capturing this and doing this, and oh, you have to manually add metadata and stuff. I mean, they're going to jump out of their skin at this point, and I've experienced this. Whatever has to be done, it has to be augmented. The job is to help them achieve those things, but in a as much automated fashion as possible, or or you have to slow down the change and you have to say, well, there's no way we can achieve it in this time period. We're
Yeah.
going to have to do it in, times X time period and get to that. And the change management, so you just described the classical change, that a very poor change management approach where there was really no change management. It's like we're going to tell them
Yeah.
what they're going to do.
Yeah. And what I find scary, I mean, you're right, with the ELN, paper to ELN, that is classic, electronic lab notebook. The other one is metadata. I mean, we need metadata. Everybody downstream saying we need metadata. Everybody upstream is keeping quiet and not generating it. And you can't win those. But I think the other thing is the cost of change. I think people have not, when an executive sits down, they've got this amazing optimism that the cost is the cost of the IT, the cost of the plumbing, the cost of some contractors or some extra informatics hires. But like you said, if you've got 40 hours a week or 50 hours a week in an individual and you add work to them, you're slowing something else down. And that creates these secondary costs. And that has to be all
Yeah.
factored in. It's almost like we're going to do things 10% slower for the first 6 to 12 months to allow us to migrate to this way of behaving and this way of operating. I've never seen an executive speak like that.
Yeah, there's two costs actually. There's the cost of change and there's the cost of not changing, right?
Yeah.
And you have to very carefully figure out what those are and come up with a plan that is human centric, and then covers the six high level processes that go in. If we're in the laboratory environment, there's six high level processes that go on that you have to cover in that change. And again, I've seen it done so poorly over the years. Many people feel like, oh, we implemented the solution, we're done, right? That's just the beginning of the journey, right? And this is where a lot of mistakes are being made on following through on implementation, configurations that need to happen, integrations. There's just a ton of work that goes on. The costs of all this sometimes are ignored because some companies wouldn't fund, that solution if they knew what the total cost of ownership
That's
was.
right. That's the point.
So there's all, and it's painful. But again, this is again in a data culture environment, all of this is understood up front. This is assessed, and then the plan is put in action with an extremely strong change management approach. And again, the sandwich approach where there's buy-in from the top down, and there's adoption from the new hires all the way up through the ranks, etc. And that's the only way to do it. And I've, like I said, we've seen this countless times.
And with a medium term view of the world, I'm not going to tell you what's happening this year. I'm telling you what happens in the next 2 or 3 years, and we've got a 2 or 3 year change management plan here, change plan here.
Right.
Should we talk a little bit about the AI bit? So there's a stack here, isn't there? There's data, and then there's AI, and then there's problems. and
Yes.
and the AI bit is kind of like the elephant in the room, because we all talk. I mean, what was it? We were at the SALS conference right on the first Monday, I think the 27th, and January the 27th, $1 trillion was taken out of the US stock market, bang, like that, because of the work going on in DeepSeek. And suddenly the whole world is front and center talking about AI this, AI that. But if we go back, this is not the first time. It's not the first time. AlphaGo, when
Aren't these hype events? These are the results of hype, right?
yeah.
Would you say that's a fair statement?
Well, that's a very good perspective. So hype has a connotation in it. Hype means it's not real. It's a hollow box which is demonstrating potential, but actually what's happening here is not real. I would say the reaction was a hyperbole, so I agree with that. $1 trillion is a lot to lose on the stock market in a few hours, even if the US stock market. And it's not like it's recovered fully. But I would say that some of the technology going on here is very scary. Not scary, and I don't mean scary from a AGI, from a general intelligence point of view, but I mean it's scary from these are step-up events. These are serious step-up events. And let me put it in perspective. This particular model, the DeepSeek R3, they trained this model on NVIDIA hardware and probably some other hardware. The NVIDIA hardware, NVIDIA's main products is called H100. They released it recently. That's banned. You can't send that to China. You couldn't send that to China if you wanted to. Maybe some found a way there, but that's not the point. But what NVIDIA sold to China, which was allowed, is something called the H20. And the H20 actually does not have the floating point restrictions, which the H100 is very strong floating point. It has a stronger memory, and you have 3 dimensions. You have floating point, you have memory, and you have your throughput. And they were able to put more memory onto these chips than the H100, but lower on the floating point. And they sold these H20 like 10,000, 500,000 or something. And when they sold it, it turns out that the new type of features and functions in these large language models called reasoning, they actually work better on H20 cards than they work on H100 cards. So what you found is a very innovative team of about 100, 200, 300 people in China, very, very strong technical team, being able to design a system with what apparently looks like lower quality hardware, but actually it's better.
Let me ask you a question about this, because this is interesting. Do you think at the time of this sale, because this is going to come out if it hasn't already, I've been so heads down busy with things, I haven't had a chance to really look into a lot of this. Do you think it's going to come down as the sales process, the pre-sales process, the sales process to this, that they knew, like you know what technical sales are because you've done this, right, in your life. You're in the weeds trying to sell something to somebody based on value and need, right? Do you think during those interactions they knew that this was actually the case, that these chips, even though they're not chips, these GPUs are going to be more beneficial to this program or project than the other ones? And it was a way around that restriction?
You mean NVIDIA?
Yeah.
Yeah. So the technical people on the front line may have had a smell of it, but I think DeepSeek would have probably restricted what they told them, because if NVIDIA found out, they would have sold it to other people. So NVIDIA's job, every company's job is to maximize your sales, right? Maximize your value. So DeepSeek were really doing this undercover, but and they did the amounts of programming. So NVIDIA have something called CUDA, C-U-D-A. That's a software layer. And what you do is you use CUDA, and it's an orchestrator to using all these GPUs. What DeepSeek did is they went underneath. They avoided CUDA, and they went to the assembly language, right to the bottom, the most basic machine language they could get on the cards. And they've created optimization algorithms at that very, very low language level. It was intense work they did. Now, I'm fairly certain that people in NVIDIA knew something very, very big was going on, but they would not have had all these details. I'm fairly certain of it.
Right.
Fairly certain. Because if they did, it would have been a way of them to leverage to other people.
Okay, so there's questions. Where did the data come from? Right. So those are some of the questions. Now there's accusations going back and forth around
Yeah,
that.
that's right. So the accusation is that in large language models, you do pre-training and you do post-training, and then you do something a bit cool at the end, which is reinforcement learning. And this is the cool.
Yes.
And the older models don't do that RL stuff, but the new models. But to do reinforcement learning, which is a form of post-training, you kind of need a lot of Q&A. And what the argument is they went to ChatGPT and they ran ChatGPT extensively to get a Q&A test set, which is the training data for their RL, for the reinforcement learning for their model. Chances are it's true. Chances are that this is all very true. Well, what's going to happen? Because they're shielded, right? They're a shielded outfit.
Yeah.
They're protected.
Yeah.
So these things
complexity. Go ahead.
No, go ahead.
No, I was just going to say that you brought up an interesting point here, is how it affected the global market, the U.S. market, $1 trillion. It was all managed, right? It was a blip. This is a fascinating part of this, right?
But it's not hype in the sense that it actually is real technology. It's not like I've seen other hype cycles before. This broke through on the use of LLMs. So you and I.
Oh no, I totally agree with you on that part. What I'm saying is, hype has driven the investment in the community at that $1 trillion level, and things like this can occur when there's a hiccup or there's a massive. This is very innovative, right?
That's right.
They worked extremely hard to be innovative here, and that event caused a massive trade event.
And that's the notion of the hype cycle, balloons popping. And so, yes, there was a buildup, and there continues to be a buildup. I was reading today, I think I was watching CNBC, and they were talking about how Amazon Web Services is now the preferred player, because what they've chosen to be is neutral. Now, if you're a neutral player now and you're not investing tens of billions of dollars, and that's how much it's costing, Meta investing $60 billion in their development cycle. If you're not one of those 3 or 4, 5, I think 5 or 6 maybe, who can invest that sort of money,
correct, then
why don't you just be a neutral player and use whatever comes? And if they beat themselves to commodity, those builders, those developers, better for you, because it's just cheaper for you to provide it. So now it's back to the gold rush. Now the winners are the people selling the shovels.
Correct.
But I think this is very interesting. Very interesting.
So it's really interesting what you said there. Things have not changed in 150 years, right?
That's right.
Just like you said, and people don't realize that there was the gold rush. Oh my gosh, I'm going to find gold and I'm going to become rich. And it's like, it's even like other things, horse racing, right? Oh, I'm gonna get horses and I'm gonna train them and they're gonna win the Kentucky Derby. The chances of that are so slim. It's the support models around it where the money's made. And for instance, the shovels and the picks, the hardware, selling to all these people who thought they were going to get rich by going and looking for silver or gold, is the hardware stores are the ones that actually made most of the money.
Yeah, but I want to be a bit careful of this conversation. All these companies are seeking some threshold.
Yeah.
And let's say if there's a performance curve and there's a threshold up and it's getting closer and closer. We're not sure how close they are. And I won't call this threshold AGI, artificial general intelligence. I'll just call it really super cool capabilities. And if they can reach this threshold with their capability, they suddenly will dominate. I mean, dominate. And this is the way, for example, Elon Musk thinks. And that's why, I don't know if you have a news today, but he offered $100 million for to buy
billion,
to open AI.
billion
No,
dollars.
100, was it billion? Yeah,
Yeah,
billion. Yeah, 100 billion. Where am I going with this? 100
we
billion.
could have bought it for 100 million.
Yeah, 100 billion. And I mean, I think he's playing them off, right? I think he's just trying to create some issues in the market because Sam Altman's trying to get a 300 billion valuation for a raise. And if he comes along and offers 100 billion, he's going to create second thinking on the investor side. But that's all the games they play. My point is this. There is a point of no return where the first of the post is going to get a lot of win. I'll put it in this perspective. If you look at the space rockets, SpaceX and the Starship, you can see where he's going. He's the only player in the US at the present moment. Of course, you've got our friend Bezos, who's trying to be but he's a long way behind with his playbook.
Yes.
But he's the only player. He's got reusable rockets. He's charging much less. And if you look at every play he does, unlike Apple are followers, but they do it really well. Musk is always a leader into the game. So he rules there. Tesla, he's not quite won yet. And the reason not quite won yet is because there's a lot of safety issues with Tesla cars because of the image, because he doesn't use LiDAR. And then but he's got other things like his Starlink system, which I think is called Starlink, which is massively brilliant when you look at it. I mean, he'll dominate as soon as he gets that constellation of mid-level satellites up. He'll dominate that field. Your first sort of post owns it, and that's true for large language models as well. I want to come a bit back to the context of our discussion today. The point here is that if I've got a lot of data and I've got a lot of commodity tools, AI tools I can use, including large language models, including old age, linear regression and random forest, and then these fairly complex machine learning models, right? I can powerhouse this data. And that becomes really appetizing. I mean, now for the first time, I can not only predict things, I can not only simulate things, but I can even replace people in making decisions in science. And we saw this at SALS, right? We saw at SALS, the conversation is, all these workflows going on now. If you look at these lab machines, they're connecting and they're making decisions, they become more automated. Automated is good. But now we can put some software aboard which not only looks at the data and looks at know-how, but thinks about what do I want to do next? What costly lab step makes sense for this business next?
Correct. And it's no secret, but that tacit and institutional knowledge that we're capturing is a big part of that, right? And that workflow. And again, people get nervous about this, but scientists that are on their game and highly knowledgeable and driving that next generation of scientific data, experimental data, and things like that, it's always going to be there. But they're just going to do it much more efficiently. They're going to have a lot of guidance. They're going to have a lot of simulation in silico first approaches to say, hey, we're going to run all this before we actually physically do it to hedge our bets that it's going to work or it's going to give us what we think it's going to. And if we don't, then that gets added back to the learning pool. And and then the next it goes again. So that's where it's at, and that's where it's going to continue to go to.
If they can get the data culture correct.
Correct. This is what it's all about. And it's been proven so many times, but if you have an effort and you statistically approach that effort, statistically you're going to get better outcomes. And people will fight it sometimes. The scientists will say, "Oh, I don't need that. I know what I'm doing. I'm going to do this." And what happens many times, not always, there's super brilliant people out there, right? And they are actually the model that things become. But they'll keep making the same molecules. If, for instance, if they're a medicinal synthetic chemist, they'll make the same types of molecules. Their novelty and diversity isn't there, and they're not going to get the outcomes that they're looking for. But if you're in this approach where you're driving in silico design simulation. A lot of people call it the design, make, test, analyze. We call it the ideate, um, and then simulate, design, make, test, analyze. And that approach is much, much more efficient than the old school, just the DMTA approach.
But we've still got a massive amount of skepticism. The FDA hasn't approved many drugs through this, which are, say, quote unquote, data first.
Right.
Hasn't really made a difference in our industry. So how do we nudge things into a little bit more like first, second, third gear type thing?
Yeah, that's a great question. I think part of the FDA is, okay, again, a very large governmental agency. It's it's bureaucratic. It's a great agency. I'm not taking away from it. Who would I be to say anything? But what comes with that is public policy change. So anything that you try to do in mass to change takes, with a lot of effort, 5 to 7 years to change.
Right.
So they could be the limiting factor, right? There's always a weak link in a chain, or a limiting factor in a reaction, whatever that is. That you have to identify that, and that's where you have to start to influence that change in more detail and more effort, and it's got to be done very well. And I think you're right. I think these are some of the issues where the private institutions will get there faster, and unfortunately the bureaucratic ones will come later, unless some sort of concerted effort happens with
But
them.
even if you separated private from bureaucratic, private from public, but even in private world, right? We've got some who are digital first. You gave the example earlier,
Yes.
Netflix and Amazon and these different domains, and you have some biotechs which are heavily into this, but it's not like they've succeeded on benevolence, Exscientia into Recursion. I mean,
Yes.
they're very good tech, but they're not the winners in the industry.
They're not yet. It's almost like the concept of taking 2 steps back to take 5 steps
Okay, that's
forward, or
good.
whatever that. Yeah, right. So I firmly believe that, for example, at Recursion and others, there's some of that going on. They're putting a massive effort in place. I think I think at the end of the day, too, you brought up I think size is a problem, right? Companies, organizations, societies, they get too big
Yeah,
to manage,
yeah,
right? This is one of the biggest problems in our world, right? If you look back at Native American culture back in the 1700s, before that, we didn't know too much about them, but they had societies that grew to a certain size. And let's just use 500 as hypothetically. If they reach 500, they agreed that they would split the community in half,
right.
and the tribe would set up, a distance away from this other one and that one, and that's how they would bud out and do things, so they could manage the tribe and the community, etc. For us, we just get bigger and bigger and
Yeah,
bigger and bigger and
yeah.
bigger, and all that inefficiency, all the problems come into play. And that's just one of our biggest challenges today, and that's what makes some of these large biopharmas very bureaucratic, um, and almost government-like, because it's unwieldy and it gets too big to manage. And we have examples today where some CEOs and executive teams have done a really great job, but even then, they still have issues that are difficult because of size.
Yeah, no, I can't argue. I mean, big companies in general. My question to you is that you've got those, and I think you're right that you got one step forward, 2 steps back. You've got to take the long view on the value of data and use of AI and data. You're going to fall over for a few years, and then you're going to get it, and then you're going to be first to the post on making it happen. The
Right.
rest of the laggards, if you think about the tail, a lot of these private companies want to do it, but they can't. They just don't have the kind of like emotionally they get it, but they don't have the skills, they don't have the teams. Are they going to die? Is there going to be a rupture in the way the ecosystem is set up, and we're going to have a lot of people in the graveyard, in the cemetery, and we're going to have a few winners who are just going to take full advantage of this? Or are they going to be able to somehow jump aboard? Let's use the cars manufacturing as an analogy. Is Tesla and the two or three companies similar to Tesla going to survive, and GM, Ford, and the rest of them just going to, they're just going to fall out?
Yeah, I mean, I think there's only I get I have to be careful how I say this because complexity is a big part of drug and therapy discovery, right? We only know we don't even know a fraction of the
Yeah.
biology out there today. So it's just so there's always opportunity to do more and be successful, uncover, discover. Um, I think um, companies in the next 5 years that are have poor data cultures and approaches to data-driven approaches in silico first are most likely going to suffer. I don't know if they're going to die, but I don't think they're going to be the top five pharma in the world. And I think some of the top pharma in the world today that weren't necessarily like recursion approaches and stuff, they're all learning very quickly and
Yeah.
they are putting things in place they are highly advanced with their AI efforts and their approaches. Um, and many of them aren't. Um, so I don't know if they're going to die or they're going to quickly buy their way in. This is the nice thing of being on top of the world with large cash reserves is you can buy your way out of these problems sometimes. Now, you can buy your way out, but you again, we get back to that organizational and that change management bits of things. If you don't do this properly, you don't set the culture after these acquisitions, you're going to be in a world of hurt. So I think some of them will go away, and I think some of them will be part of an M&A strategy to help them get there if it's well thought out.
Yeah, I think you're spot on the money. So if you've got a lot of small to medium-sized biotechs who aren't data heavy, but they've got strong biological, chemistry, disease, compound type skills, they may become targets for the data companies to swallow them. And
Right.
that makes sense because you do have two classically different domains here, data driven and science driven. And it's creating the harmony between these two, which will win. You can't win with just one. That's the key.
Exactly. And there is an evolutionary path of a startup biopharma where it pains me to say this, they can get away with it for a while
Yeah.
where they're poor data culture. And it's because I call it human horsepower or human hero driven.
Yeah.
You know, their CSO or their head of research or it's a combination of titles because the founder was brilliant, was able to do all these things. They had an extremely good idea about the approach. Um, um, and they understand things like mode of action, target, etc., and they're successful, right? The problem is that's fantastic, but to repeat that and to scale that, not just grow that, is where the challenge is at. And they either get acquired at that point or soon after that, or now they have to figure out how to go from being the brilliant toddler to the accomplished teenager or young adult in that evolution of their company. And that's where the sooner you start the data culture and the data is an asset, process is an asset in your DNA fabric as an organization, the much better off you're going to be. The people that wait for it is usually at a point where it's almost too late and extremely painful to change.
Yeah, and they won't have the margins in the deliverables, the time,
Correct.
won't have the money from the investors, and they'll be very much under a lot of gun to get something out of the door like IND, pre-IND,
Right.
or for some development milestones with a partner or something. Totally.
I've been involved in fixing companies that had horrible data culture, horrible data environments. Companies were coming to buy them. And there's one where somebody offered $1 billion and they said, no way. And we revamped that company and they ended up getting $5 billion a couple years later. So this is the value too from an investment perspective or a sale perspective. It's crystal clear the difference in value from that perspective when someone was willing to pay for it. But the true value comes within the environment itself and the capabilities and the ability to discover, not only innovate, ideate, innovate, discover, and take it to market. That becomes a machine, and that machine has high value.
Yeah, it's the people. It's back to the people, back
Yep.
to the culture, back to culture. Listen, this has been great today. I really appreciate the conversation.
Yeah, no, this is a first. We'll keep talking about things like this. I'll be the first to say I don't know everything. I'm always learning, and that's the fun part of all this. Um, but I like to share these experiences and what I think, and you may not agree with it, but you may send us a note and saying, "Hey, I heard what you said, and I have some ideas on this I'd like to share with you," or I'd like to see if I can change your mind on something, or if you could change my mind on something. We love those conversations. So we're just really working hard to evangelize and change the data culture out there so that we get there faster. I say to people during the COVID pandemic, if we had better data environments during that horrible experience, but we might have gotten through things faster. We might have saved a lot of people's lives. We might have prevented misinformation. So this is what I think when the rubber meets the road and we have real world evidence, real world data, and we can make much better decisions for the world. We're all going to be in a better place.
Yeah, I agree, John. And so for folks viewing this, listening to this, as John said, please do reach out, please do comments. And if you've got ideas, topics, questions, yeah, we're here. Thank you, everybody.
All right. Take care, everybody. Enjoy yourselves. Stay healthy.